Welcome to another edition of New Scientist's Video Roundup. I'm Jessica Griggs, taking you through 3 of our favourite videos from the past week. We begin with some remarkable footage from the bottom of the ocean, showing the world's deepest living fish for the first time. Scientists filming in one of the world's deepest ocean trenches have found groups of highly sociable snailfish swarming over their bait, nearly 5 miles beneath the surface of the Pacific Ocean. This is the first time cameras have been sent to this depth. Although some species of snailfish live in the shallow water, the Hadal snailfish are found exclusively below 6,000 metres. Here they have to contend with total darkness, near freezing temperatures and immense water pressure, equivalent to 1,600 elephants standing on the roof of a mini car. They feed on thousands of tiny shrimp-like creatures that scavenge the carcasses of dead fish reaching the ocean floor. Here we can see that the groups are sociable and active, yet living in one of the most extreme environments on Earth. The deep-sea equipment needed to survive the extreme pressure at these depths was designed and built specifically for this mission. Next we have Rowan Hooper telling us about a technological breakthrough in the digital reconstruction of embryos.
This is the digital embryo of a zebrafish. It's the first time a complete developmental blueprint of a vertebrate has been digitally encoded. To make the blueprint, scientists tracked all cells in a zebrafish embryo for the first 24 hours after fertilization. This data was then reconstructed into a 3-dimensional digital representation of the embryo. In order for one cell to become a complex organism, it has to divide, travel around the body and form specialized tissues. Here they are dividing and growing to form an embryo made of 20,000 cells. The best way to understand the process is to look at what happens in the first few hours of life in every part of an embryo, and that's what a new type of scanning light microscope was able to do. Footage like this will be made publicly available to provide a new resource for research and scientific training.
And finally, has New Scientist uncovered Spider-Man's secret for sticking to walls? The answer came in the form of geckos. Geckos have long inspired scientists with their ability to scamper up walls and cling to ceilings with a single toe. US chemists now claim to have created a material that is 10 times as sticky as some gecko feet and just as easy to remove with a tug in the right direction. This tiny square of material can support over 1,600 grams when pulled roughly parallel to the surface. Here we can see the team testing the substance for stickiness by attaching it to glass and suspending a container of water from it. So how does it work? A gecko's toes are covered in microscopic hairs known as setae, with even smaller branches at the top, called spatulae. The research team created artificial setae by growing a forest of carbon nanotubes on a silicon wafer. The entangled free ends of the tubes act just like setae, imparting strong hold but also effortless removal. Future uses of the substance could include adhesives, solder replacement, and, according to its inventor, even superhero suits if there's a serious need. That's all for this week, but remember there are plenty more science and technology news stories on our website at www.newscientist.com, including India's first mission to the moon, a fossil discovery reveals how the turtle got its shell, and the amazing bug found in a gold mine whose DNA may be the key to alien life. See you next time.